quadratic functions in all three forms, standard, vertex, and factored form. And what we're going to focus on today is converting between standard form and vertex form. We're going to think about this question here first. The path of a football as it is thrown by a quarterback is modeled by the function h of d is negative 3d squared plus 3d plus 1.95, where h of d is the height of the football in meters when it's d meters from the quarterback. Describe how to determine the maximum height of the ball and when it occurs. So that just went in one ear and out the other for me. So let's try and highlight and look for the important information while we read it. The path of a football, okay, is modeled by this function. H of d is the height of the football in meters when it's d meters from the quarterback. Describe how to determine the maximum height and when it occurs. And lastly, we're going to underline our units and what we're looking for when we read it again. Path of a football as it's thrown by the quarterback is modeled by that function. H of d is the height in meters, d is in meters. Describe how to determine the maximum height. So I'm finding the maximum height and when it occurs. Do I have the skill set to solve for that? Possibly. If you came through grade 10 academic, yes, you might have an idea how to tackle this question. If you came through 10 applied, maybe not. I do know from my skills that I learned this semester that this question could easily be solved using the vertex form equation. And if I have it in vertex form, the maximum height is k, and it happens h units from the quarterback. However, it's not in vertex form, and I don't know how to put it there yet. The other option I have is factored form. So I can find my zeros, which are r and s in this case, add them up and divide by 2. That will give me the distance from the quarterback, and I can substitute that in to find the maximum height. However, let's look at that equation. It doesn't look nicely factorable to me either. So that requires our need to learn to complete the square. Now, I tried to record this lesson already once and give you an explanation about why I'm doing what I'm doing. But I just got all tongue-tied and it didn't sound clear to me. So if you want me to explain to you why I'm doing what I'm doing, come and talk to me, or we'll talk about it a bit in class tomorrow after you've seen a few examples. Okay, so don't worry about why it works right now. Just worry about learning the pattern and kind of getting an idea of what you're doing, or trying to look for why it works and connect it to your knowledge of perfect squares. The idea would be I'm trying to create that perfect square, x minus h squared, to find the vertex. So when this is a perfect square, this was double the product of the two terms inside. So remember, your middle term is 2 times x times negative h. So when I look at my third term, it's going to have to be whatever that number is divided by 2 and squared. I've altered my equation, so I have to keep in mind that I have to take it away, because when I add those two together, they equal 0, and that's really important because I don't want to change the function I'm working with. So f at x squared is x squared plus 2x plus 1, take away 1, plus 3. And if I look at these three terms here, that's a perfect square trinomial. X squared is a perfect square, 1 is a perfect square. They're both positive. And I copy the sign from in front of the linear term, and it's plus 1 squared. Negative 1 plus 3 gives me positive 2. And remember, if I check my middle term to make sure my perfect square works, it's 2 times x times 1. The 2 was this 2, so I had to divide it away. The x came from the square root of this term, and the 1 comes from the square root of that term. If we work backwards, it makes the divide by 2 and square it a little more meaningful, but it's a little hard to explain in a video. And again, if you want to understand that connection, please ask me about it in class tomorrow. Please come and see me. Okay. If I look at this question, the a value is positive 1, which means the function opens up, and it has a minimum then, and the minimum is positive 2, and it happens when x is negative 1. Or really, we could think about it when x plus 1 is 0. And there's a nice written explanation of the steps we did. If I look at this one, the problem is when I look at my numbers in the brackets, the x is always positive. So I have to factor out the -1. When I factor out the -1 from positive 4x, it becomes a -4. The -7, we're just going to leave alone. We're not going to bring it into the brackets because we know we have a k value generally, which should be outside the bracket. So we're going to leave that one alone. Now we have x squared minus 4x plus, again, we're going to take this number in front of x, which in this case is -4. We're going to divide it by 2 and square it. And in order to keep the equation balanced and not change it, we still have to subtract it off and subtract 7. That leaves us x squared minus 4x, and 4 divided by 2 is 2, and square it, it's plus 4 minus 4, take away 7. If I look, these three terms form a perfect square, but inside the brackets, I've got that -4. So I have to use my give friend the distributive property and take that -4 out of the brackets. So this equation becomes negative x squared minus 4x plus 4. And I take the negative in front and multiply it with the -4 and subtract 7. And again, I've forced a perfect square in these brackets. It will always be a perfect square. So square root the x, square root the 4, copy the sign from in front of the linear term, and I've factored it. Now negative 4 becomes plus 4, take away 7. So it subtracts x minus 2 squared minus 3. The a value is negative, so my function opens down, and I have a maximum of -3 when x is 2. And again, there's a prettier solution that's easier to read and copy later on. Okay. So if I go back to the example I started with, I actually know how to solve this question now. Oops. So if I do this, I've got h of d. I'm going to factor out the 3, and I'm left with d squared minus d, because of course I'm dividing this positive 3 here by -3, and I'm leaving the 1.95 alone. Now the coefficient here is -1, so I'm going to do -1 divided by 2 and square it. And again, I have to subtract it off to keep the equation balanced. And I can use decimals because 1 divided by 4 is 0.25. It's a nice decimal, and I'm already working in decimals in the equation. So what's nice is I'm going to let you switch to using decimals for this question. We won't always have that opportunity because sometimes decimals are not terminating. Before we can complete the square on the perfect square, we do have to remove that fourth term inside the brackets. So we get d squared minus d plus 1/4. Subtract 3, because remember that -3 has to distribute with it, and I'm going to just change that to 0.25 right now, because we did say we could work with the decimals. And I can factor the perfect square trinomial. Square root of d squared is d. Copy the sign straight down. Square root of 1/4 is 1/2, which is 0.5 squared, plus 0.75, plus 1.95. So h at d is -3 times d minus 0.5 squared, plus 2.7. So the maximum height of a football is 2.7 meters. When it reaches a distance of 0.5 meters from the quarterback. And before class tomorrow, please attempt exercise 1, pages 2, number 1 to 4.